Dear students, welcome to today's lecture on transforms and boundary value problems. In this lecture, we will begin Unit 1 Partial Differential Equations. We will discuss the basic concepts of partial differential equations, including their definition, order, degree, linear and nonlinear equations, homogeneous and non-homogeneous equations, and finally learn how to form a partial differential equation by eliminating arbitrary constants through solved examples. First, what is partial differential equation? Differential equation classified as two types. One is ODE, ordinary differential equation, and one more is partial differential equation. So, partial differential equations have a lot of applications in real life, solving real life problems too. What is partial differential equation? A partial differential equation is one which involves partial derivatives. First, we have to know what is the order and degree of a PDE. How to find, first of all, we have to find what is the order and degree of the PDE. So, order is nothing but highest derivative. Degree, power of highest order derivative. So, we have to see the examples. So, before that, we want to know what is linear. So, when a PDE is said to be linear, if the dependent variable and the partial derivative occur in the first degree only and separately. So, if we see in using some examples, which means, for example, dou z by dou x plus dou z by dou y equal to 0. This is linear equation. This is dependent variable. X and y are independent variable. So, we have to write z equal to f of x comma y. So we have to write z equal to the function of x comma y. So here, what is the order and degree of the equation? So order of the equation is 1, degree. Degree also 1. So order and degree also 1. The dependent variable z, independent variable x comma y. This PDE classified linear and nonlinear equation. So, basic definition to understanding. Derivatives appear only to the power is called linear. Derivatives appear with powers greater than 1 or as products is called nonlinear. For example, linear PDE. See, the first equation, dou z by dou x, dou z by dou y is a linear equation. Order and degree also 1. Here dou z, dou square z by dou x square. 3 dou z by dou x. This is multiplied but with constant. So this is does not affect the linear equation equal to x plus y. So this is also linear equation. Next, this is also linear equation. Next, non-linear equation examples. See, this is the whole square. The degree is 2. That's why this is non-linear. The degree is 1 means we have to see this one is linear, but here the degree is 2. So this is non-linear equation. This is also non-linear. This non-linear equation defined based on this term because the dependent variables multiplied with their derivative. That's why. So the last equation, dou u by dou x, dou u by dou y, dou u by dou z equal to x by z. So multiplied with the independent variable. Therefore, these three equations are called non-linear equation. So the first equation degree and order is 1. Here, what is the order? The order is 2. The degree is 1. Because linear equations always degree is 1. Here order and degree also 1. Next, that linear PDE again classified homogeneous linear PDE and non-homogeneous linear PDE. So here, what is homogeneous linear PDE? Always the equation LHS side 0. So equation LHS side all equal to 0 means we have to blindly write that is homogeneous linear equation. So this homogeneous linear equation have no external source term because maximum external source term appears in LHS, that RHS side. So non-homogeneous linear PDE. So always the right hand side non-zero. The example, dou z by dou x, dou z by dou y equal to x plus y. Next, and also here maximum are here. This non-homogeneous equation contains external and force terms. So that's why this equation is called a non-homogeneous linear PDE. So next, here in unit 1, we are going to solve the problems. So if we see in the first case, if number of arbitrary constants less than or equal to number of independent variables. So this is the first case. So what is the first case? If the number of arbitrary constant less than or equal to number of independent variable, then we get the PDE of order 1. Therefore, we have to use P and Q only, which means, so we are defining the derivatives equal to some of the letters. So dou z by dou x, these are called notations. Dou z by dou x equal to P, dou z by dou y equal to Q, and then P, Q, or S, T, then double derivative also we have to use. For example, in upcoming case 2, case 3, case 4, we have to use dou square z by dou x square equal to R, dou square z by dou y square equal to T, and next one dou square z by dou x dou y equal to, and then dou square z by dou y dou x equal to S. So these are the notations we are following in eliminating arbitrary constants model. Why these eliminating arbitrary constants are essential? What is the essential difference between the ordinary differential equation and PDE? When both are found by eliminating arbitrary constants, what is the purpose? Which means, because the order of an ODE will be the same as the number of constants eliminated. The order of a PDE will be 1. Listen, the order of a PDE will be 1 in cases when the number of constants to be eliminated is equal to the number of independent variables. But if the number of constants to be eliminated is more than the number of independent variable, the result of the elimination will be in general, which means it is from the second order and higher order PDE equations. So now we are seeing only that not higher order, only a linear equations. So this is the first model. So upcoming problems, you have to know how to deal with these problems. So first we have to take some simple problem. So first, form the PDE by eliminating the arbitrary constants A and B, form Z equal to AX plus BY. So you have to remove these A and B constants. So you have to remove this A and B constants. So we are using that first case. So in first case, what is the given? So the given is Z equal to AX plus BY. So first we have to do differential. Partially we have to differentiate equation 1 with respect to x and y. So partially we are differentiating means what we get? Dou z by dou x equal to with respect to x. With respect to x means a plus 0 you will get. Dou z by dou y with respect to y, what we will get? So first term does not have y. So 0 plus b into 1 you will get. Next, so you will get dou z by dou x equal to a, dou z by dou y equal to v. So as per the notation, what is dou z by dou x? Dou z by dou x equal to p, we already know. Dou z by dou y equal to q. So apply this into this into this, what do you get? P equal to a, q equal to b. Now apply this to equation into equation. Put this in equation 1. So what is equation 1? Z equal to ax plus by. So if you are applied this p equal to a, q equal to b, what you get? Z equal to px plus qy. So this is the solution of this equation. You are eliminated the arbitrary constants. Next problem. Eliminating the arbitrary constants a and b from z equal to x square plus a, y square plus b. See, the same procedure we are following, because what is the case 1? If number of arbitrary constant less than or equal to number of independent variable. Independent variable here z, arbitrary constants are a and b. So we have to form the PD of order 1. Therefore, if we are using P and Q method, the P and Q only. So first, partially differentiate equation 1. Partially differentiate. So now, first partially differentiate equation 1. Partially differentiate equation 1 with respect to x and y. So here x, here y. So how to do the differential? Partial differential dou z by dou x is that equation. Differentiation with respect to x. So see the first term, x square plus a. So x square differentiation 2x plus 0 and then multiplied with y square plus b. This is multiplication, not addition or this is multiplication. So what you get? 2x into y square plus b. Next, dou z by dou y, differentiation, partially differentiate with respect to y. So now the z equation, what is your z equation? X square plus a into y square plus b. Always check the in between that in between that equation is multiplication or addition or subtraction. We have to clarify this. So partially differentiate with respect to y means the first term does not have any y. So consider this is as constant. So this one differentiate with respect to y. So 2y plus 0. Y 0 constant differentiation always 0. So you get 2y into x square plus a. So now, so what you get finally? Dou z by dou x equal to 2x y square plus b. Here dou z by dou y equal to 2y into x square plus a. So already we know dou z by dou x equal to p. This is p and q only. Dou z by dou y equal to q. P and q type. That's why we have to use this one. So apply p equal to 2x y square plus b. Here q equal to 2y x square plus a. So now just alter the equation. Just swap the equation. Here also 2 by q by 2y equal to x square plus a. So now this is 2. Now this is 3. So now apply 2 and 3 in equation 1. So what is your equation 1? Z equal to x square plus a, y square plus b. So what is your second equation? P by 2x equal to y square plus b, q by 2y equal to x square plus a. So apply here z equal to q by 2y into p by 2x. So now you will get pq by 4xy. So now arrange the equation 4xyz equal to pq. Now the constants a, b are removed. So which is the required PDE? Which is the required PDE? So these two problems are very simple basic problem to understand the case 1 PD formation of PD equation. Let us try one more equation. You can try. This is the third equation. X minus a whole square plus y minus b whole square plus z square equal to 1. So try this one for homework. Thank you.